if we want to draw shear force and bending moment diagram, so that is not possible in FreeCAD. For that, what we need the output of the analysis. Here we got the output of the analysis, but the one simple problem is that this is a 3D mesh. So in 3D mesh we have to extract information by ourselves. See, for the first point there are 8 nodes. You can see that for drawing a bending moment diagram, what we can do is we can take let me show you in the graphically. So here is the nodes. See, at the first point the color is I will just take this example. There are 8 nodes, this 1 2 3 4 5 6 7 8. The defined, what we defined is a circular element. The meshing the meshing which has the meshing was done by the calculus engine, like with 8 node points. Okay, now what we can do is we can take either the middle the point which is in the z direction downwards minus z, and in the where this point is y is equal to 0, z is in negative space. Okay, and x will be in positive space. Like we can collect all the information regarding these points, like this point, and next in this node this point, after that this point. See, the between these two it seems this node only have 4 points. That is maybe due to the meshing, 3D meshing itself. This is the mesh or the node point which is created by the solver. This is what we have defined. We have meshed it to have 1000 millimeter elements. So from this node to this node it will be 1000 millimeters. The center node is created by the solver. We can extract the information for this node, and we can do it like all the nodes. We will get the bending stress, the I don't think the shear stress will be varying along this direction, so we can only get the bending stress at these points. Okay, that's one possibility. And for shear stress we can use these points which are in the central on the x-axis plane, where z is equal to 0, y is in either positive or negative space, and x is in positive space. Okay, we can take this point or this point. That is some tedious work, to be honest. So what is another solution? Let's take a look. Okay, for time being switch off this node. Okay, now go to, either we will okay, what we'll do, we will can we duplicate this? Can't. Can we copy paste? No. We'll save it. Merge document. Okay, we will save as FreeCAD 2D. Let's do 2D analysis. Okay, I think the previous one is gone, I guess. No, previous files are saved. This is a new file has been written. That's fine. What we have to change is go to analysis and go to the solver, click on solver settings. This is a temporary file. Okay, write input file, edit the input file. This is a very important step. In the input file where it says output node file output 3D, change it to 2D. Okay, if we do this, one part is done, but the same report of stress and strains is reported in the output file. If we want directly the shear force and the bending moment, what we can do is we can comma space section forces. If we put section forces and output 2D, and we have to save this file, just click on Ctrl S or just save it and close it. And then, and if you can keep track of the folder, so this will the folder where the output file will be written. Now run the calculus. Now the analysis is complete. Okay, you can close this. See, here is the output file. So this is the output file. So in this output file, the first 3 points what we defined 0, 4 and 8, correct. And then we defined a node while meshing for every 1 meter. So these are all the extra points that are created. First concentrate on these 3 nodes. Let's go to the GUI. Now if we click on displacement, we can see that maximum displacement is 0.493 meters. Okay, now bending stress. The maximum bending stress 0.931 Newton per Newton meters. I'm not sure is it correct or wrong. What's happening, I'm not sure. Give me a second. This is shear stress. The maximum shear stress, see you, it is hard to visualize because there is no surface. You can't visualize what's happening in the FreeCAD. Okay, let's see. There are nodes, node file. We will hide the mesh also. 1 second. Okay, these are the nodes. The shear stress, I will go to shear stress and I will take it as nodes. Okay. Now also I can't properly. Let's switch off these forcing parameters. The red dot, the final red dot is 5.05 e power 110. I mean that means 50 newtons. 50 newtons. No, I think it is wrong. Just purge the results. Let's do it one more time. 1 second. Now the displacement is 0.5 millimeter. Now the results are showing correct. Bending stress 9.3, and it is same. Shear stress this will be 19.45 kilonewton minus, okay, nodes. Fine, let's analyze the output file. See, at point 1 what the result we are expecting is 105 kilonewton shear force at point A. Okay, at point A 105 kilonewton. So this is point A. Displacements, and here is the point A. The shear stress, no, in the 2D analysis space the things will be changed. For this will the reaction, this is 105, this is 104.99 kilonewton, that is almost 105, correct. And at point B what we got is 44.99, 45 kilonewton. So what will be the thing is 45, correct. So that is correct. See, and here we will also get the moment. This is the moment. Yes, this is SYZ plane. In 2D analysis these planes will be like they will be exchanged, like in 3D for shear stress we have to look at ZX plane, but in 2D we have to look in the YZ plane. And you can assume like the Z the Y is the Z is replaced by the Y. So however, so this is how. What we can do is we can take this data and plot the BMD and SFD also. Let's see we will how to do it in this next video.